Hello, everyone. I'm Mike Apley from Kansas State University. I teach production medicine and clinical pharmacology here at Kansas State. Today, I'm going to be talking about the future of antimicrobials in food animal medicine. Struggled a little bit with exactly what context to put this in, but I went back to the basics of clinical pharmacology, being a clinical pharmacologist, and put it into four basic components of clinical pharmacology that I think describes how we as veterinarians and food animal producers are going to be addressing antimicrobial use in the future. And that's, can I do some good? Can I do some harm? Can I get it in the animal? And what does it cost? And of course, can I get it in the animal means, do I have a reasonable regimen I can use? So when we break down, can I do some good? We're talking about welfare and conservation of animal resources, which is one of the things in our veterinary oath. Then when we talk about, can I do some harm? In the past, a lot of times we've just thought about direct toxicity, but also regulations, residues, and market chain access. Today, we have different market chains with very specific requirements. And by recommending or using an antimicrobial or a drug in a certain manner, we could make it impossible for our client to sell into the market chain for which they prepared the animals. And again, the practical regimen, we're going to come back to about different ways of looking at the cost. But when we start breaking out, can I do some harm? Before we talked about direct toxicity of the drug, regulatory harm, residues, market chain access, and of course, regulatory would include having a violative residue at slaughter. But today we include considerations such as the microbiota and the environmental resistome alteration. What could we be doing in the population of bacteria that are not necessarily associated with our direct pathogen of interest? And that leads also to resistance development and direct pathogens for the animals and foodborne pathogens. That's really a tough part of the equation to get a handle on with direct evidence. A friend of mine has told me that if you understand antibiotic resistance, it hasn't been adequately explained to you. And I think that's a very astute observation that's incredibly complicated. And the fact of the matter is, we're going to move on in the next decade without having a lot of that settled, which makes it difficult to include that in parts of our equation. And then maybe cost isn't just about the price of the drug. The cost could be in resistance. The cost could be in market chain access. There are a lot of things in there that are externalities, different costs that aren't necessarily related to science. If we're going to talk about the future of antimicrobials, we need to talk about the past. So if we look way back in 1910 and 1912, we basically had arsenical compounds that the goal of these compounds was to kill the bacteria slightly before it took you out. So they weren't a very friendly drug, but they were the best we had. In 35, the first sulfates came out for use. In 42, we got benzylpenicillin, which is procaine pen-G as we know it. Tetracyclines in 48, and then here they came. In the 40s and 50s, we had all these first members of our groups, and it was really fascinating to see these all come in. And then by the 85, we got the carbapenems, and then it started to slow down. And we've got the linezolid, a member of the oxazolidinones in 2000 and 2003, daptomycin, one of the cyclic lipopeptides. If you look at the ones that we use in food animal medicine, the last year we got a new drug group that is a direct action antibiotic that we use in food animal medicine. It was 1978. So we're a long ways in, way over 40 years since we had the last new group. We've had new members of the groups, but they're the same basic chemistry. We now have some new novel compounds being developed on the human side. There's over 40 compounds in development worldwide, but only about 4 of them are new, actual unique classes, unique mechanisms of action. This just illustrates that in food animal medicine, we're not going to have a whole lot of new tools. We have the ones that we have. We need to move forward and be sure to conserve those. And it's all wrapped up in antimicrobial stewardship. And I was glad to see the AVMA put significant time into developing an antimicrobial stewardship definition. And one of the really big things is that as a profession, we are obligated to preserve the effectiveness and availability of antimicrobial drugs. and we have to utilize responsible medical decision-making and safeguard animal, public, and environmental health. It's a great definition. Sometimes getting down into the details can be a little challenging. They have gone forward with some further breakouts, but coordinated interventions, improve and measure the appropriate use of antimicrobials. So that measure is a big part that's in our future, and looking at the optimal regimen, dose, duration of therapy, and route of administration. We use a lot of single administration antimicrobials in food animals. We're very fortunate there, but in our daily administered drugs through the feed or through the water, and some injectables, and also in the human medical field, we are woefully under-supported in how we make a reasonable decision on duration of use. The duration of therapy supporting data just isn't there for us. And in my way of thinking, as we look towards the future of antimicrobial use, we really need to sort that out. We want the optimal clinical outcomes, minimize toxicity, reduce costs, limit the selection for antimicrobial resistant strains. And there's another component where we could definitely use more research, but so much of what's going to happen in the next decade is going to evolve around what we know, what we think we know, and what we're scared we don't know, the unknown unknowns, in relation to selection for antimicrobial resistant strains. And some parts of the world have dealt with that with the precautionary principle, where unless you can prove it's safe, it's out. We haven't gone there yet in the United States, but when you're worried about what you don't know to be worried about, sometimes we get awfully conservative, and conservative meaning being very reluctant to allow much use of these compounds. If we look at stewardship, this again defines our future. The first thing is we have to be using reasonable and appropriate diagnostics and have very accurate and functional case definitions. That is the classic partnership between a veterinarian and their client. And without those, we can't move forward and claim that we are using these drugs within stewardship and in a judicious manner. This number two part, is there a non-antibiotic alternative? This is one of the biggest parts of our future, is looking for reasonable non-antibiotic alternatives that will prevent, control, or treat the disease challenge. We already see prevention with antimicrobials prohibited in at least one state. We have other states considering that. The boundary between prevention and control is sometimes rather fuzzy. And of course, individual animal treatment is something we'd all agree we need to do. But we'd also agree we need to do everything possible to not have to treat those. So this non-antibiotic alternative component of stewardship is going to continue to become more and more into the forefront as we move forward in this next decade. And that's selecting an antibiotic which has been demonstrated as safe and effective for this purpose. That safe and effective is going to continue to take on a new meaning. And the safe part is not only going to be direct toxicity to the animal or toxicity by passing a residue through the food chain. It's now going to continue to be more and more focused on that somewhat nebulous concept of what might we be doing to select for resistance and pathogens of concern for veterinary species, and also what impact might we have on human therapy. And this fourth part, to me, is how I truly tell if a veterinarian has a VCPR. If they can tell me whether people are following their protocols they've come up together with, then I know whether or not they have a VCPR. You can have all the printed, written out VCPR agreements you want, all the written protocols that everyone signed, but unless we really know how they're being followed, to me, I'm not sure we really have the VCPR established. And this is also a tough part of figuring out whether that antibiotic intervention is still necessary. And I think that's one of our biggest challenges. But in the future, we're going to have to double up on going back and making sure that any antibiotic interventions we've established in prevention or control are actually still necessary. And then no, you stop, or yes, you go back looking for that non-antibiotic alternative. Some may look at this and think it's a little Pollyanna, a little academic, but I think it defines the steps we're going to have to be engaged in, and we're going to be watched as to how we're engaging these steps. So when we talk about those antibiotic alternatives, would you recommend or prescribe And would a client adopt an alternative which possibly raises the cost of production, requires an alteration in production practices, results in a detrimental effect on animal welfare, or risks you losing a client or incurring liability for losses? Those are the hard questions right there. We can talk about considering resistance, but resistance can be a far off concept over the horizon where immediate concerns are cost of production, maintaining production, staying in business, et cetera. How we balance that is going to be a major debate and a major focus in this next 10 years. And what would be an incentive to adopt such an alternative? If we have something that could be an antibiotic alternative with lower cost and same or improved efficacy, not going to be a problem putting that in. The market access, if people are willing to pay, regulatory penalties, preservation of antimicrobial efficacy, that last one is really difficult to quantify and put into the equation. So here's the core questions it comes down to. Do you believe your actions as a veterinarian or a producer in your use have any effect on the future efficacy of antimicrobials in animals and humans? And if yes, are you willing to take any personal risk in an attempt to minimize the effects of your antimicrobial use and prescribing? Those are the hard questions. And frankly, we have a hard time answering them with some of the data we have. If you look at what antibiotics we're using, it's really clear that we have a large emphasis on macrolides and tetracyclines. Penicillin's used quite a little bit, a lot of it in turkeys, orally in water, but the macrolides and tetracyclines dominate in both cattle and swine. I wanted to make you aware of a recent set of pilot studies through a cooperative agreement with the FDA Center for Veterinary Medicine, where we quantified antimicrobial use in 22 USB feed yards as one of the papers. And if you look at it, this is milligrams per kilogram of live weight. You can also look at it as regimens per animal year. And the study of how metrics affect your view of antimicrobial use is really important. And if you go through these papers, there's a lot of really good explanations in there from the different species. But the insets just magnify the use for control of respiratory disease and individual animal treatment for all diseases because they're so low. So you can look at the different antimicrobials, but here's the actual values. And you can see that in-feed use dominates. And in milligrams per kilogram of live weight, if you add up the macrolides in green and the purple color is the tetracyclines. If you add those up, you're at about 95% of the milligrams of drug used per kilograms live weight. If you drop it down to regimens per animal year, these two categories would make up about 85%, which emphasizes that our in-feed and in-water use to groups of animals are going to be a focus in the next few years as to why we're using them and the ramifications of using them. So we talked about resistance. This is the integrative conjugative element that we find in Mannheimia hemolytica. It carries multiple different antimicrobial resistance genes on this integrative conjugative element called the ICE, and it can be passed back and forth between our three main respiratory pathogens as well as E. coli in the lab. And this is a paper that I look at that to me illustrates what we're going to have to continue to consider in relation to resistance such as that. This was a paper out of Iowa State where they looked at isolates coming into their diagnostic lab and looked at records for how many times the animal was treated and correlated that with resistance. And what we found was, they found was that if they were treated none, once, twice, or three times, the percent of resistant isolates went up, and it went up across all drugs due to that integrative conjugative element, possibly being in there and causing multiple drug resistance. And it just shows that as we put more and more pressure in those animals with therapeutics, we can bring out those resistant subsets. So this is something to me that really shows we have an issue to deal with. So those FDA CVM cooperative agreements were made publicly available in a free access special edition and can be accessed here. I think we'll close with the FDA's view of what's going to happen in the next well, this will end by 2022 or 23, but their 5-year plan currently in effect. And the most important parts to me are that we're going to have a very clear emphasis on duration and a very clear focus that over-the-counter antimicrobial use is going to be gone by the end of 2022. Those are the things that strike me as the biggest components of explaining to us what we're going to be doing over the next decade or so. There's going to be a huge emphasis on what we're doing with antimicrobials in relation to selecting for resistance in our own pathogens and possibly having an effect on therapeutics in people, and the transparency through initiatives such as antimicrobial use monitoring are going to continue to increase, putting us more and more in the public arena for our use. With that, I'll look forward to questions.